So structured data. This is going to probably involve two keywords. Struct, which is a C keyword that was grandfathered into the language, and in class. The difference between a struct and a class conceptually would be that a struct is data only and a class can have functions attached to it. Now, realistically speaking, when they made the C++ language, they made it so that the only real difference between a struct and a class is whether the data is public or private by default, and you can stick methods in a struct. But that's a silly thought. If you want to put methods in it, call it a class. So an abstract data type. It's a data type that specifies the values that can be stored and operations that can be done on the values. So for example, you might make it some kind of data called a list, and then you can add items to the list and you can traverse the list. The vector is an example of that. It's a data type. What kind of values can be stored on it? Well, they went to a lot of trouble to make it so that you can store any kind of data in it. It's done with templates, generic data. So use the, why can't we put the word the user? The user of an abstract data type does not need to know how the implementation works. I don't know how a string works behind the scenes. I have some good ideas. How the vector is done, how the file class is done, how cout and cin. I don't know the underlying guts of those. I just get to use them. So, abstract data types are created by programmers. Some programmers wrote the specs for, IO streams and strings and stuff like that. So abstraction, the definition that captures general characteristics without details. For example, an abstract triangle is a three-sided polygon, but a specific triangle may be scaling isosceles or equilateral. An abstract sphere is something with a radius, but we don't have a specific value for that radius. A specific sphere would have a radius. So the data type defines the values that can be stored in a variable and the operations that can be performed on it. So if you have a sphere and we have to decide what the radius can be, is it going to be an integer? Is it going to be a float, a long? How big can the sphere get? How precise do we need? And then what can be done with the sphere? We might want to be able to calculate its volume. So we might make a get volume operation. We might want to be able to calculate its surface area. We might be able to want to change its radius. We might be able to want to retrieve the radius from it. So those are 4 operations, which you would call methods. Functions that are attached to it. So combining data into structures. So structure is a C++ construct that allows multiple variables to be grouped together, to be aggregated. So you might have a patient structure that has, the patient's name, their weight, their address, their, next of kin, whatever, all that kind of information on it. You might have a point class with an x and a y and a z coordinate. You might have a vector, if you're into physics, which would have not only an x, y, and a z coordinate, but it would also have the amount of force that was, its motion in the x, y, and the z directions. So for example, a student class. Student class, every student could have an ID, probably a different one, a name, what year in school they are, I guess that's like 1, 2, 3, or 4, and then their GPA. So when you're ready to create a structure of that type, or an object of that type, oh, I guess I need to upload this. Alright, so when you're ready to make a student object, a variable, Java folks remember seeing that new keyword. C++, you don't put the new keyword. Sorry for the differences in the language, but if there were no differences, it'd be the same language. And then you can set those values. S1.studentID is equal to 1, 2, 3, 4, 5. S1.name is equal to Barney. S1.year in school is equal to, I don't know whether they meant 1975 or whether they meant for year 1, year 2, year 3, or year 4. And their GPA, they're really smart, so they got a 4.1. Okay, so there we go. In this language, you could fill those fields in order, like this. At least you can in C, and I believe it's true. Right? Fill in all that information as you create it. Now that's kind of lame, because what if a programmer or developer comes in and changes this order, or they add something, right? They decide that not only do you want a student ID, but you want, what their degree is going to be, right? And so they come up here and they add a degree, string degree, like that. And all of a sudden, this is no longer going to work. So that's lame. I would not use the auto-filling. And honestly, I'm not absolutely sure that that works in C++. It does work in C. There's a better way to do that, which we'll get to later. But you can see that one variable contains all these different pieces of information. It's an aggregate of all the pieces of data that are declared as part of the student. These are known as instance variables, because I have an instance of the structure. I'm going to call it an object. I'm not sure that that's what they're called when it's a structure, but I have one object that's carrying around 5 pieces of data. And then I could create another object. I could make struct S2 and fill it in with different pieces of data. And it would not replace all that data for S1. In our prior programming, if we asked for their weight and their height, we had one variable for their weight. And then when it looped back around, do you wish to repeat, then we would store the next value in the same variable. Now we could be clever and store that stuff in arrays, but if you did not do that, then every time you enter new data in, it would be replaced. Here we're allowed to keep data separate from each other. One person could have a different height and weight than the other. So when you declare your structure in this language, you got to put a semicolon after it. So when I was writing my example structure, I managed to somehow remember to put the semicolon there. Probably because it was on the demo, right? Okay, so that helped me be real smart. I'm going to add a word here, public. If I put the word public here, it means that all these things that follow it can be accessed from the client code, from the main function. Now that was the default anyways. So I was able to do all this stuff without that keyword there. The default access for a struct is public. So the default access level for all the members of a struct is public. So we don't need that keyword up there. It doesn't break it. But that does mean that you could add some private members to it. Now why, I don't know, but you could. You could make some things that the main code was not able to change. Now if you're going to do that, then there better be something somewhere that can change it, and that would be functions that are declared as part of the struct. But once you start declaring functions, then you ought to be calling them classes. Typically, the recommendation is to name your classes with uppercase letters and your objects with lowercase letters. So when I declared my class, I called it uppercase student, but then when I used it, my variable name was lowercase. Why is that? So that as you're scrolling up and down, if you see something like this, student.reset, like that, you can eyeball this thing and go, oh, well, that's some kind of class operation. It's doing something to a class and not a particular instance, not a particular student. Just helps you visually distinguish between the two. Is it a law? Do you have to make your classes uppercase names? No. Did C++ make them uppercase names? But that's not uppercase. OF stream, not uppercase. No. The answer is that the developers of the C++ language did not follow that rule, that recommendation at all. That recommendation actually came along after the creation of the C++ language in 1980, whatever. And so the people who invented a Java language followed it religiously. So I don't care if you do or not, but I recommend it. So the declaration does not allocate the memory or create the variables. So when I did this, when I typed struct whatever, I don't have any memory set aside to contain a degree and a student ID and a name. Just like if you have a blueprint, you don't have a house, right? You buy a magazine full of blueprints, you pull out the blueprint, you're like, you don't have a house yet. It's not down until we got down here in Maine or whatever, you know, that now we have a patient. Oh, I goofed. I totally goofed there, and I apologize for that. Does anybody recognize what I did wrong in that line? This is supposed to be a patient that I'm making. S1 is supposed to be a patient. So, or student, excuse me. Patient was the last class's example. If S1 is supposed to be a student, how do I specify that it's a student? Well, how do you normally specify that something is an int rather as opposed to a float? It's going to be a long night. Nobody's paying attention to me.
Repeat the question.
How do this line is probably a syntax error. What is wrong with it? I want to declare that S1 is a student. So what is wrong with this line?
You don't have brackets to include everything else.
I don't have a definition. I don't say it's a student, right? I need to do that. Students. Now, I think that would be a syntax error. I think that that's valid. Yeah, I'm sure it's valid in C++, but not, I mean in C, but not in C++. There. Now we're saying that S1 is a variable of type student. So now we have allocated it, and we suddenly do have room. It has allocated memory for the degree and the student ID and stuff like that.
So you don't have to put struct student in that line since it's been declared as a structure.
Okay, please to repeat.
Where you got it highlighted, so one line up where you said student S1, but you don't have to put struct student S1.
If you're doing C programming, yes, C++ assumes that. So
Okay.
that is correct. You don't have to put that keyword there. If you want to, you can create an object at the same time that you create the structure itself. You could do S3 or, you know, default student or something like that. And then you don't have to go and do that before you start filling in information. Now, if you know that you need only one student, that's a valid way to do it. But there's no reason not to break it apart. I don't see any reason to do that as opposed to going ahead and creating your object like that. So as soon as we do that, student bill, all of a sudden it goes out in RAM and it allocates enough RAM to hold all that information. Accessing the structure members. Our student has a GPA, we access it with the period identifier. In this language, unlike Java, you will also see that as a way to refer to that. That's in a different context. That's if this is a pointer to a student object. We're not talking about pointers at the moment, so that's how you do it. We will see that arrow syntax really fast, though, when we start doing classes. We will use something called the this pointer, and it will be this hyphen greater than in order to get a hold of stuff. So here's a payroll class. Structure. It's got all these pieces of data in it. We make an employee object. We get the employee's number with CIN, right? Enter the employee's name, and then we write it out to that. Enter the employee's, number, and so on. I think I said name twice. It's all right. Then when we're ready to display it out, cout employee.name, employee.emp number, employee.hours, and so on. So to display the contents of a structure variable, you have to display each field separately using the dot operator, or the arrow operator if you're using a pointer, which we're not. You cannot compare struct variables directly, because a struct variable is really just something that kind of contains a pointer. It contains a reference to the address of the object. So if I do this, student S1 is equal to all that information, and then I make a brand new student. I'm going to delete this one right there because that's not too cool. And then I made another student who had all the identical information, student S2. And then I do something like this: if S1 equals S2, cout yay, else cout nope. Got too clever by half there. All right. That'll never say yay. It doesn't go by contents unless you go to some great deal of effort. It's like you have two street signs. Just because the houses look identical, if you ask if street sign 1 is equal to street sign 2 or street number 1 is equal to street number 2, no, they're not. Now, if you happen to have two street signs that point to the same house, yes, the street signs are identical. So if we do this, student S3 equals S2, those guys are equal. So if we do S3 is equal to S2, then do some whatever, right? This would trigger, and it would always trigger, because they both point to the same block of memory. Unlike Java, this language supports something called operator overriding, meaning that you can change what equal does. We could change what that does when given to objects, and we could make it actually do a comparison. But what is that comparison going to comprise of? It would have to check every piece of data. So what we normally have to do, if we weren't going to be that clever, is do this. If S1.degree equals S2.degree, and so on down the line. S1.studentID equals S2.studentID, and you get the idea. S1.name equals S2.name, and so on. That's how you compare objects. They're not calling them objects, they're calling them struct variables. Okay. Somewhere somebody decided that structs were not objects. They are. Initializing a structure. You can initialize a structure when you create it, and I demonstrated that. Or you declare the variables, you initialize them after you created it. I also demonstrated that, and then I deleted this one because I said it was tacky. The reason I said it was tacky is if somebody comes in and adds a new member of the structure, then this no longer works. Or if they change the order, it's broken. If you want, you can initialize only some members, but you're filling them in by order. So in my example, I add a degree to it. The first one always has to be a degree, and I can leave the rest of them out. They'll be all set to 0. In their example, since they don't have the degree, they only had student ID and these other 3, then if you only specify the first value, then that's the one that gets it, and the rest of them are set to 0. Until some fellow employee comes in and breaks your code by rearranging the members. That's Let's make it look like I'm showing Vincent's grade. I'm not, but all right.
Yeah, please don't show my grade.
Yeah. All right. Take care of that possibility. So here's our employee class. Name, employee number, pay rate, hours, gross pay. They create the object and they initialize it with an initializer list. Now, when I showed that parentheses syntax, that's a C syntax, I said I wasn't sure that would work. This is telling me that this definitely would work. That looks just like the initializer list for an array. So I need to remember that in the future and not show you the other one unless you're taking my C class. Arrays of structures. It's almost time to actually do some examples of this in Visual Studio. What lecture are we on, guys? I closed my windows. V, we're on V, alrighty. And I accidentally created a C# app. Brilliant. I should show you the difference, but we're going to have to talk about classes more than. Race you to the boilerplate. Alrighty, so we're going to declare structure. Often people would say declare the structure in a header file so that they could be shared by more than one program. So why don't we do that? I'm going to come over to source files. I'm going to create a new file. New item. It's going to be a header. And the name of this class, I'm going to make it a point. It's going to have an X, Y, and a Z value. Point.h. So, struct point. It's got three pieces. Int x, int y, int z. And it is legal to say int x, comma y, comma z. Doesn't matter. Quite often at the top of a header file, you will see the words pragma, #pragma once. What that means is that even if this code is imported multiple times, if it's #included multiple times, the compiler catches that and only includes it one time. And you might ask how that would happen. Well, what if you had two other header files that also included the point class, right? If you were going to declare a circle and you needed a point class in it, so in the circle file you did #include, point, and then you're creating a box, and the box had, a whole bunch of points on it, so you did #include point there. Then when you were compiling and it hit multiple #include points, it might compile incorrectly. This prevents that. Make sure that it won't generate an error. Okay, so I have a point class. Excuse me, I'm calling it a class. Structure. like I said, in this language, structs and classes are actually indistinguishable except for the behavior, whether these parts are public or private. Okay, so over in main, in order to use that, I'm going to have to # include it, but I'm going to use double quotes rather than angle braces because it's in the same directory. So # include, double quotes, point.h. And I'm ready to create a point. Point P1 equals angle brace 1, 2, 3. Those are the coordinates of my point. Point P2. P2.x equals 10, semicolon. P2.y equals 20. That print's maybe too small for you. Colon. P2.z is equal to 30. Now, did I have to line them all up like that? No, I did not. Do you have to put every structure in its own header file? No, that would be considered unusual by C++ developers. Java developers do stick every class in its own file, usually. You don't absolutely have to, but it's considered an incredibly poor taste. Alrighty, so there we go. We have two classes. We could do whatever we wanted to with them. Let's make a line of code that will print a point out. So it's going to be a function called print. It's going to take a point pt as its parameter, and it's going to see out the word point, then it's going to see out x space equals space end quote arrow arrow pt.x, and then it's going to see out space. I'm going to take these spaces out there like that instead. Y is equal to end quote arrow arrow pt.y. And then see out arrow arrow quote space z equals end quote arrow arrow pt.z. And then followed by an ENDL. So after I've created these 2 points, I can print them out. Print P1, print P2. And if I run it, it might actually work. Yep, it printed them out. If you were doing object-oriented programming, if you were writing a class, you would make this print method, this print function, actually part of the point class, so that you would be able to call it like this instead. Now this isn't going to work because it's not there, but you could do p1.print and it would print it. Now why would you do that? Because you would like for all of the functions that work on a particular class, on a particular object, to be attached to that class, so that you can call them easily. You don't have to worry about looking up in some which .cpp file, which header file, or whatever happens to have your little print function. If it's defined as part of the class, you know where it is. It's part of that class. But we're not there. Any typos, anybody? Nested structures. I may skip that. One thing I will point out, though, and I think I've mentioned it before. Oh, a lot of people, maybe I just didn't ask the question right. But on the exam, which type of parameter will allow a function to change data that was declared outside the parameter, outside the function? And the answer is references and pointers. So, the deal is that if I pass in by reference, it doesn't create a copy of the object. When I do this, when I call print like that, it allocates enough memory to hold a pointer. It's not a pointer, a point. I'm beginning to regret calling that structure that. It allocates enough memory to hold all the contents of P1, and then it copies every value into it so that it can do all this stuff with it. You can also just say, no, pass me the variable itself. And in that case, you use the reference operator. But you got to go down here. Nope, you don't have to change anything down here. I was thinking about C#. That saves memory, speeds things up just a wee little bit. If you do that, you might want to declare this as constant. That's right, that's stating that this method will not change the contents of PT. Otherwise it could, right? Because we're passing it the variable itself. If we were mischievous, we could say x, pt.x is, don't do this, pt.x is equal to 0, right? And it would wipe out p1.x when we called it. You don't have to put const if it's not a reference, right? Because if it's not a reference, then no matter what happens in here, the original data is still preserved, right? I just gave this function a photocopy of my data. So if you're going to use references, but it's not going to change it, you may as well make it a const. And the PowerPoint's not going to mention that. Yeah, let's look at it. Nested structures. Oh, I see what they're saying. Here's what I thought they meant. Structure circle. And then inside the structure circle, I defined another structure. Point. And it's got an XY point. And then I seal it off, and I say that that's my origin, right? Every circle has an origin, something like that, right? That probably would compile, except for the fact that I'm reusing the word point there, so I'm going to call it p-point. I'm going to just cut and paste this, see if it works, satisfy my curiosity, then I'm going to delete it. You can do that. You can declare a structure inside a structure. You could also declare a structure inside a function. What if I want a function here? I mean a structure here, I could do that, Struct box. And a box has a height and a width and a depth, right? Now why would you do that? The only place you could use that structure would be in main and not in any other function. But you can. So, just like you can declare a structure there, you can also declare a structure in a structure. That's what I thought they meant by nested structure. What they mean is to do this. I have a circle structure, and it uses my point class. So this variable is of type point. So I guess it is a structure within a structure. And then we have a radius as well. So when we allocate a circle, ew,
Does that marker actually show up on the board whenever you do that? Or is that just for us? On your videos, I should say.
no, it does not.
Okay.
Right, right.
Just curious.
I need some kind of tablet here and some more sophisticated software, and you can tell that it's supposed to work that way. And this thing didn't work up to 3 months after it was installed. So, very good question. All right. So when we do circle C1, I hope y'all can see this. Can everybody see it? I know the glare's bad. Do I need to go turn the lights on bright, turn this off, or are we okay?
We're fine.
Okay. When we do that, what happens is it goes out to RAM. Our point has what in it? What were the variables that we declared in point? X, Y, and Z, right? So, and each int occupies 4 bytes. And now we have a radius. Say we made that a double for some reason. Then it goes in and allocates 8 more bytes for that, right? And so all of this is dedicated to X, all of that is dedicated to Y, all of that is dedicated to Z. And then the next 8 are dedicated to the radius, and the compiler figures out which is which based on the structure definition. Okay, just to show you the difference between using a reference and a pointer to access a structure, I'm going to copy this and change it to print by pointer. So I'm going to call it pprint or something like that. So there we go. Maybe I'll even call it print by pointer. Belabor the point. It is common practice to name all of your pointers beginning with the letter P, just to indicate that it's a pointer. Now this variable name that I chose already happened to be a P. But just to differentiate it between that and that, I'm going to do so anyways. Now notice that all of these are wrong. Well, besides the fact that I have the wrong variable name, which I can pick by doing ppt dot, to access the elements of it by pointer, I need hyphen greater than rather than period. You Java people never see that because the Java language does not support pointers, nor does it support references. Okay, there we go. Like that. Is there any reason why you would use one over the other? No, absolutely not. Not that I can think of. Why don't we Google that up? Advantage of pointer over reference. Well, advantage of reference over pointers. The advantage of a reference is that you can't be passed bad data. But I could easily pass in bad data into print by pointer. What would that look like? If I did this, print by pointer, and I passed in 0, like that. Oh, all lowercase, excuse me. But I tricked it. I said, nope, I didn't even need to trick it. Now it probably wouldn't crash. Never know if it'll crash or not. Let's find out. Right, but this is obviously not a pointer to one of our objects. It's just 0, so it should not have an X and a Y and a Z. So when we run it, is it going to, yeah, kabooey. So code that is written to use pointers is inherently less safe. That's why they were left out of Java. That doesn't explain why references were left out of Java. If you have a choice, go with references. Reference can be considered a much safer pointer. So this is dumb. What if we really wanted to print one of our good objects, though? What if we wanted to print by pointer P2? Well, P2, but we would put an ampersand in front of it to say, I want the address of that. Or I could declare a pointer to that object and store it. I could do pointer, or point, P2, a pointer to P2 is equal to the address of the P2 object, and I could pass that in. Both would do the same thing, except I'm getting an error there. Oh, because I forgot to declare it as a pointer. To declare a pointer, you use a star operator in front of the variable name. So what this is saying is that this variable is going to contain a memory address. And the memory address is one that we should hold the address of a object, a point object in. You can mess it up, like I said. You set it to 0 and you pass it in and it blows up. Would you want to do that intentionally? No, but it can happen anyways. So anyways, that would work. Or passing it in with the ampersand would work, means the same thing, like that. That's the structures, yeah. So if we have this origin and we want to make a circle, right? Circle, I have no idea how to allocate a circle using this nomenclature. We could take a guess. Do we do it like this? 1, 2, 3 to fill in x, y, z, and then 10 is the radius. Is that acceptable? I don't know. I don't know if that's acceptable or not. Instead, I'm going to do it the long form. I allocate a circle, and then I do c1 dot origin dot x is equal to 3. I'm going to copy that because I'm going to set y and z equal to the same thing. And then the radius of it's going to be 6, or yeah, 6. Can I type 6? Doesn't matter what it is. So you see that we're actually using 2 dots to get a hold of it. Why? Because here's our object, and the origin is another structure, so to get to the x element of it, we have to use that variable name, that object name. However, radius is nothing special. It's just an int. So we only use 1 dot. Can you have objects inside of objects inside of objects inside of objects? Yeah, in which case you might have dot, 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 dot. You know, a whole bunch of things separating it. Structures as function arguments. Well, I just did this. Pass in the entire structure? Sure, you can do that. Pass in a single element of the structure? Sure, you can do that. GPA is declared as a float, I think. So you would write a function that accepts a float. And it accepts a float, well, it could accept a member of a structure, it could accept a constant, it could accept, whatever can be converted to a float. This is just the same as our print. We wrote a display or a print function that took a point. So here we have a structure called inventory item, and we have a show function that accepts an inventory item as a argument. So we have an inventory item as a parameter here, so it can accept an argument of that type. And it prints it out. Ooh, and it does it all fancy with show point and set precision. Okay, so prints out p.partnum, p.description, p.onhand, and the price. And then when we call it, they don't show us calling it. Fine. When we call it, we would make an inventory item. We might fill it in the pieces of data as we created. It's part number 1. It's a description. It's a widget. It's on hand. Yeah, we have 10 of them on hand, and their price is $1.99 a piece. Then when we're ready to show it, show item, and we pass in I1 like that. Those two things should be together. I don't know why they didn't show an example of it. So, using a value parameter, which is one that's not a reference or a pointer. for a structure can slow down the program and waste space. Now, the smaller the structure is, the less important that is, right? Just passing around that point structure with 3 ints, well, big deal, right? If you were going to pass, but what if it's some kind of structure holding the data for an 8 megapixel photograph? You don't want your program to have to allocate enough RAM to duplicate that object every time you pass that photograph around from one function to another. So, you can use a reference parameter. Speeds it up because it just copies the address of the variable in. But then the function is technically allowed to change the data in the structure. Maybe that's what you want, maybe not. If you, the programmer, do not want that function to be able to change the data in that structure, you use a const. That's everything that I've already said. It provides read-only access to that reference parameter, and it does not waste space or speed. So here, that's what they did, is they modified their show item to declare it as const and to be a reference type. Returning a structure from a function. You can a structure is just a variable. Anywhere you can return a variable, you can return a structure. So what if in our code we want to make a new point? So I'm going to make a function that returns a point, and I'm going to call it PT factory because it makes new points. And it's going to take an x and a y and a z. So int x, int y, int z. Alrighty, so point p dot x equals x, p dot y equals y, p dot z equals z. And then return that point. Excuse me, return p, because that's the point that we allocated. So down in main, if I so wanted, I could create a point in that fashion as well. Point, new PT equals PT factory, and I could pass in those 3 values, 100, 200, whatever, right? That's nudging up to the idea of a constructor. A constructor is a function that's part of a class that makes the object. We could move this PT factory function into the point struct if we wanted to. And if we did that, then we would be able to pass in that data as we created it. But like I said, once you start adding methods to a structure, change its name to class, because that's what people think classes are, is things with data and functions bundled together. Don't change it if you're modifying somebody else's code in there, depending upon it being a struct. Okay. I guess I should run and make sure that works. Yeah, it worked. I mean, I didn't print anything out, but at least it didn't crash. We could print it out, right? We have a print function, print P1, so here we could do print PT. Print parentheses, new PT, lowercase t. So yes, you can declare a function as returning a value of that type. So here, they're demonstrating the prototype for a function called getStudentData. It's supposed to return a student, so they put that as the return type. So what happens? The function has to return a local structure. It has to create one, and then it returns it. It would be a... Nah, I'm not going to even say that. So here's getStudentData, right? It creates a student, and then it asks the user for all that information. Asks the user for the name and the address and the city and the year, and it doesn't even tell them that they're supposed to be typing all that, so that's interesting. And then it returns that student. We could do that in our point class, right? We could ask for the values of x, y, and z. I said point class, in our point factory function. So pointers to structures. So a structure variable does have an address, and the pointer to the structure is a variable that holds that address. So if we want a pointer to a student structure, student star. The star means this is going to be not a student, it's going to be the address of a student, the memory address of a student. And then when you're ready to fill it in, you use the ampersand operator. My pointer should contain the address of the student1 object. And you can use pointers as function parameters, as I did in my print by pointer function. So when you print out, oh, this is a good point, blah, blah, blah. When you create a pointer, if you're going to access the data that's in the pointer, here's how you do it, right? If I'm going to make a pointer to an int star pi. And now I need to declare an int I is equal to 3. Pi is equal to ampersand I. Now what if I want to print out I, but I don't want to print it out by its name? To access it, int y is equal to, here's how you access it. You do star pi. This is called dereferencing it. The star means go to the address that's stored in this variable in order to get the data. But why is that important? Up here we have a pointer to this structure. And so to get the elements out of it, if we want the x value out of it, we could do this. Int my value is equal to pp2 star in parentheses dot x. Now that looks tacky. But that works. It's the same thing, technically, as int my value 2 is equal to pp2 dash greater than x. Which syntax do you like better? I don't know, I like the second one better, but that's because I've seen it a lot. I know we've only talked about pointers a couple of times, but I hope this is clear. I hope that this part is clear, what we're doing here. This variable is not an int, it's the address of an int. And so to use it, we had to put the address of an int in it. Otherwise, it's just null or some random value. And so we use the ampersand to get the address of I. Get the address, the memory address of I, and put into pi. And now access that data by its address. That's what's going on there. And this is an int, and this is a pointer to an int. A pointer is probably an 8-byte data type. That would be my guess. I would imagine that every pointer in C++, no matter what it's pointing to, is 8 bytes. And why do I think it's 8 bytes? I think that it's got to be a long in order to hold memory as large as what PCs come with nowadays, right? Like 16 gigs and stuff like that. Because an int, 4 bytes can only hold values up to 2 billion, right? It's about time to stop. This stuff's kind of weird. Strongly, strongly, strongly recommend reading the chapter. Don't just go by my lecture. Even if you think you're not going to become a programmer. I've had people who started off as electrical engineering students, or they got an electrical engineering degree, but they'd taken some programming classes, and then they got a great job being a programmer rather than an engineer, and they liked it, so whatever. I know some of y'all going, no, I'm not going to be a programmer. That's fine. All right.